This is the programmable load that you can use to test batteries that I sent you yesterday. Hopefully you'll get it maybe tomorrow as I'm making this video. It consists of a power supply for the tester itself. This is the tester. I sent 2 spare power transistors. The power transistors go way under here, underneath that heatsink. A couple of clip leads that you can use to hook up to things to test, and a couple of coaxial power adapters, because some USB, this thing can test USB power sources, and this fits many of them. It also happens to fit some batteries that I use. It's a standard coaxial jack. So what I'm going to do is I'm going to get into how to hook up to the thing and how to operate it in the various modes, and how to use this magic button, the push button. So now I'm just going to plug it in with nothing attached to it, so we can go through kind of the basic operation. The connector plugs in right here for the power supply. It's it says 12 volt, but it's actually a 9 volt module. And so now I'm going to plug it in. And what you can see is this display lit up, and it's up and running. Everything focuses around this display, these 2 knobs, these connectors right here. There are other connectors around the board on the back and on the side. Ignore those. Those are for other modes that we don't use. Fairly sophisticated testing modes for Qualcomm type power management in cell phones. We're going to ignore all that. We're just going to go through the basic functions. So as I said, this area right in here is where all the action happens. This is for adjusting the current load on a battery, or the current load you're putting on a USB power adapter. This is the fine adjust, and this is the coarse adjust. They're terrible controls. They go very, very fast. So especially when you're on the coarse adjust, you need to go very, very slowly on a battery, because this unit's capable of sucking down 20 amps out of a battery. And you don't want to let it do that to the kind of batteries you're using. All operations take place through that one button. All menu selections, changing of values, and so it gets a little tricky. And I emailed you a list of 6 operating items on how to use that button, and we're going to demonstrate a few of them. This over here is the primary power input. You can hook up a USB adapter here, or you can hook up a battery here. That's the positive terminal, that's the negative terminal, and they're actually marked on the underside of the board. You have to look underneath the board to see which is which. And these are 3 USB connectors for plugging in a USB type power adapter, like a 5 volt power adapter for your phone or whatever. These are the 3 different connector styles, and we're going to demonstrate actually first how to use this to look at a 5 volt power supply. And that's the basic operation. Now there are a bunch of operating screens. This is the one that came up when I first powered it on. When you do it, it may or may not do that. It says we've got 0 volts on the input. Makes sense, because nothing's hooked up. It says we're running no current whatsoever. And then here, this is where when you're running a test, it'll show you how many watts you're using. Right now it's 0. This 18 degrees C is telling you the temperature of the transistor, the big power transistor. That's really, really important. Don't let that get over, I would say for a while, 40 until you get more confidence. I took it up to 85, and that's when I burned a unit up. The last test apparently ran 0.4 amp hours that I ran, because this thing saves its data, and used 6.3 watt hours. By the way, I'm demonstrating my unit, not yours, and so your numbers will be different. And the last test I ran for 10 seconds. That's probably, let's see, no, this is a brand new one, so maybe that was a test at the factory. I don't think I've ever used this one. Okay. This is kind of the same thing, just in a little bit different format. I don't know why they do that. But again, the current voltage and the current amperage, and the duration of the test that's been running, and the temperature, and I don't know what that ohms is about. I think there's some way you can test resistors with this thing. And then the watts, the number of amp hours accumulated, and the number of watt hours. Same data, just rearranged. Okay. Now we're getting into one of the first setting screens, and it says BL on. That's backlight on. Do not ever, ever, ever turn the backlight off. I did that once by accident. By the way, you just saw that when you're on one of the subscreens, it times out. And in this case, it goes to what it thinks is the home screen, which is the Chinese version of all of this stuff. So you'll run into that screen on as well. Anyway, if you turn off the backlight, you cannot see what you're doing when you're trying to press that button. And it was a real bear. It took a long time for me to braille my way through trying to get the backlight turned on again. So never, ever, ever turn off the backlight. So I'm pressing this button one at a time and going to different screens. Those are the ones we already went through. There's your backlight screen. Okay, this one, it's going to time out on me, but it says greater than 300 volts. This thing has a protection in it. If you ever apply more than whatever this is programmed to be, it will shut it off, and the only way to get it restarted is to unplug it and reboot the thing. So it protects itself from high voltages. I'm not going to mess with that because I don't think you're ever going to put anything like a destructive amount of voltage into this thing. Okay. So again, I'm pressing the buttons one at a time. I got to get back now. There's your backlight. There's the one we were just at. This one is really important. This is telling you the lowest voltage that you will pull down something to. So if you're running a battery, if you have a 3S battery, the lowest voltage you want to take those cells is 3.2 volts. So 3S, that would be 9.6 volts. So you would set that value to 9.6, and when you're running a battery life test, it would never pull below 9.6. Now, you could actually go a little lower than that because there's DC resistance in a battery, and if you're pulling a couple of amps, which is what we talked about on the phone, or 4 amps, you'll be able to see when you first hook it up and start pulling that current that the voltage drops immediately. That's not from the battery discharging, that's from seeing current going through the DC resistance. So you can go a bit lower than that 9.6, probably 9 volts or even lower than that is safe, and you're still okay with your batteries. But if what you're doing is just trying to see if your battery life changed, then pick 9.6, it's safer, and always test to 9.6 and write that down in a notebook. And then the next time you test, you can compare how long it took to pull it down to 9.6, and you'll see how your battery life is changing. I'm not going to change that right now because the first thing I'm going to test is a USB power supply. And this thing can pull a USB power supply down to 0. That doesn't hurt the power supply. And so I don't want the thing tripping out on me. So I'm going to leave that setting at 0 volts for my first demonstration. I'm going to go through the rest of them. So here we go. We're going backlight on. Here's the high voltage. Here's the low voltage. This is the current. It's set for 100 amps. I'm going to change this one. So to change it, I double click and it went up 1. If I triple click, it goes down 1. Once it's set a direction, once I've double clicked to get it up or triple clicked for going down, that's the direction. And if I press and hold, it will simply, oh, I timed out. So I'll get back to that. The timeout's kind of annoying, but I'm talking, so that's why. So I'm going to, it also has a maximum power level that the thing will take before it will trip out and shut down. That's just like the overvoltage. You have to unplug and reset to get it to come back to life. I'm not going to change that because, again, I don't think you're going to be anywhere near that power level, especially after I limit your current. So now I'm going to go up and I'm going to limit my current instead of your current. I think yours I set to either 5 or 10. Okay, so double click, it went up. Triple click, it went down. So now I've established a down direction. Press and hold, and it starts scrolling down. So I can scroll down to about 10 or so, because that's the most I really ever want this thing to suck down. I don't even want it to take that much on the batteries I test. Maybe I'll go down to 5 on the batteries I test. It's really just a safety rating. You're going to control how much you pull by those knobs, but it is possible to pull too much. So maybe for my test, I'm going to take it down to 4, because I have 4 amp hour batteries. That would be 1C. So now no matter what I do to that coarse power adjust, it will not take too much power or too much current, and I'm probably doing the right thing here. Oh, okay. So I did just, I let off the button because I was getting close to 4, and then I pressed it once, and instead of doing what I wanted, which was decrementing more, it went back around to the main menu. So now I have to go back around. Okay. Whoa, it went too far. Kind of drives you crazy a little bit. Okay, triple click, triple click, triple click, triple click. So now I've set the maximum current this thing can draw to 4 amps. Oh, now I'm going to go around here. So I'm happy with my settings. I got 0 volts for the low voltage cutout, and I've got 4 amps plugged in. So now what I'm going to do is I'm going to hook up a USB power source into one of those connectors, and we're going to actually operate something. So what I've got here is a relatively hefty 5-volt power supply. It's not a USB source. It's rated at 2.5 amps output. It uses this style of connector right here. So I got it plugged in now, and right here into this connector. And it's showing I've got 5.27 volts, and I'm not pulling any current yet. So what I'm going to do is I'm going to start to adjust the fine adjust and pull some current out of that USB source, or out of that power supply. Okay, now I'm pulling 320 milliamps. The voltage dropped to 5.2 volts. Here the fan kicked on. It does that as soon as it's starting to dissipate any power whatsoever. It's a little annoying on the reflection on the thing. I'm going to get a card and block off one fan because we're not going to be running much power here, and I won't want to be able to see that display. Okay, that at least there, so that blocks the reflection there. So what you can see is I'm pulling now 0.86 amps out of this power supply. It's still got 5.05 volts, and we're showing that we're getting 4.24 or 34 watts. The watt hours and the amp hours and so forth may be, I'm not sure they apply to this at all. I've picked up the crib sheet, and the crib sheet says if I do a long press on this, it will reset all the data. Well, that appears to be a lie. I'm holding a long press and it's not doing it. If I do a double press, it's supposed to reset milliamp hours. Ah, that reset. I can reset the power, the watt hours, with a triple press. That reset. I can reset the time with 4 presses. Okay. So now my time started from 0 and it's counting. I've actually accumulated now 1/100th of a watt hour. That really only matters for a battery. Who cares what the watt hours are on a USB connector, because you could run it forever. Okay, so I'm going to run this the fine control. I'm going to keep going up. So I'm at 1.5 amps. It's doing pretty good. It's still at almost 5 volts. Okay, and now I've run out of fine adjust. So now the tricky part. To get on the coarse adjust, I'm going to turn the fine all the way down, and I'm going to turn the coarse up really, really slowly. Okay, and it kicked in, and the first thing it came to was an amp. So you don't get a lot of help with that on the very small end of the range. So I'm going to give myself, I got up to 1.5 amps before. Okay, so there's almost 1.2. Now I can go back to the fine and go up from there. So I get up to 2 amps. I'm down at 4.9 volts. This is a pretty good power supply. I'm impressed. Yeah, there we are. I'm pulling 2.5 amps and it's 4.9 volts. I would say that little power supply lives up to its reputation. That's a legitimate 2.5 amp power supply. It's one of the best ones I've seen. If I keep going up, the voltage keeps going down, and now I've exceeded 4 amps. I don't know how I exceeded 4 amps, because I told it to never exceed 4 amps. I turn it down, and nothing happens. If I unplug, I don't know how to reset from this. If I unplug, it goes, I accidentally pressed the button, so that might have been the thing that restarted it. Anyway, that's a test of a simple USB, or okay, now what I've done is I've plugged in an actual USB power supply. This happens to be the source and the cable from my camera. So it's plugged in right here. It's a USB Type-C. At zero current, it's running 5.12 volts. I'm going to try the long press again. Well, I don't know. Somehow it actually reset. I didn't see it reset. Okay, so I'm going to start turning up the voltage, or the current, I mean. You have to turn it quite far before it starts to draw any current at all. Okay, there we are at only 200 milliamps, and it's already down to 4.9 volts. At 500 milliamps, which is probably as much current as it would ever draw in a charging. I'm finding these USB things that say they're 2 amp and 3 amp chargers, or that's kind of bullshit. 4.74 volts, going up to 1 volt. I got 4.29. And when I get to 1 amp and a quarter, I'm down to a volt. So the thing fell off of a cliff here right around 1.2 amps. Well, that's not bad. That 4.2 volts might have been useful for charging. Well, I didn't capture it on video, but you can see the display is reset to zeros. And in fact, pressing and holding that button for just a couple of seconds actually reset the numbers. So I don't know if you have to be on a particular screen for that reset to work or just when it resets, but it did work. And if it didn't, you can go back and reset each item individually, the amp hours and the watt hours and the time elapsed. This is the battery I use with my fish finder. It's a 18650 cells, and it's a 4S2P. Its rating is 4.4 amp hours. I'm not going to test it all the way through on this, but I'm going to show you an actual battery test in operation. At full charge, this thing is sitting at 4.2 times 4, 16.8 volts. And the minimum I want to let it get it down to is 3.2 times 4, so 12.6 volts. So what I'm going to demonstrate right now is programming the current, the minimum voltage to 12.6 volts. So I scroll over to the right screen. I don't forget which way is which, so I'm going to go 1, 2, and that appears to be up. So now I'm going to take, oh, that's current. 1, 2, 3 to go down, take it back down to 4 amps. Okay. So I must have gone around to, oh, it was where it was saying 0. That's 0. So double click to go up. Now I'm going to scroll, I've pressed and held. I'm scrolling up to 12.6. I'm hurrying, boss. Double clicks take me one step at a time. So now I'm set to 12.6. So single clicks to get me back around to my test screen. And it says now I'm under 12.6 volts, and it's unhappy about that, which makes sense because I got nothing plugged in. Okay, so now I've plugged in the battery. I used a cable right here attached to the binding post on the power input. And that's because I had a mating cable, because that's the kind of battery connector I use. And you can see over here in our magic area that's so important to us, it's showing 16.6 volts because it's a fully charged battery. I took the card away. We're going to have some reflection problem here as we film this. I'll try to get as much on it. Whoop, now I got overhead light reflections. There, that helps. But we're going to get some reflections from the light on the fan, unfortunately, but I do want this one to be cooling. So now, if I can increase the power, or the current. Notice that when I did that, the clock timer started running. When I turn it back down again, the clock timer stops. So the thing is smart enough to know that I'm not accumulating time when I'm turned all the way down. I'm going to hit the button on a long press and see if the time resets. Okay. So now to run a test, if I want to pull, well, I said on the phone, this is a 4 amp hour battery. Well, first let me demonstrate what happens on the voltage when I increase the current. Okay, notice the voltage drops immediately. So I'm getting up here to that's 1.5 amps, and I'm down more than a volt. Okay, the battery, I'm going to turn it down. The battery didn't discharge. That is DC resistance on the current trying to flow out of the battery. So you could probably, on your safe minimum, add a volt in, and you still haven't discharged the cells themselves below their safe limit. For now, I'm going to leave the limit where I had it. Okay, so I'm going to get this thing up to, I notice that the ohms are changing. That must be the current divided by the voltage. That's interesting. So somehow you can use this thing, I guess, to measure a resistor value, perhaps, or tell you the equivalent resistance you've got on it. So I'm at 2 amps. Notice my temperature now has climbed up to 23 degrees C. So I'm going to stop this video at this point and come back a few minutes from now. We'll see where it is. Okay, so we're 12 and a half minutes into the test. And you can see that we have accumulated 0.42 amp hours, 6.28 watt hours, 12 minutes and 50 seconds in. Transistors are 29 degrees. I'm real happy with 29 degrees. And we're pulling almost 29 watts, 28.94 watts. Now what I'm going to do is I'm going to turn the current down here and show you that the open circuit voltage is nothing like that 14.6 volts. So if I turn the current all the way down to 0, I still got 16.1 volts. So this battery is still quite charged, even though it says a much lower voltage. So now we're going to go back to our, what was I pulling, 2 amps before? Let me turn it back down just a little bit. So we'll let it sit there for another 10 minutes or so. So I didn't quite wait 10 minutes. Would have been at this so far 21 minutes. We're up to 10 watt hours, 0.72 amp hours. We're pulling 29 watts. The temperature's at 30 degrees centigrade. I'm really happy with that temperature at 2 amps. You're running a 3S battery and you want to run at 4 amps. So what I'm going to do is take this 4S battery up to 4 amps. While you weren't looking, I increased my current limit up to 10 to give me room to do this. So I'm just going to pull this guy up to 4 amps. Oh, I almost hit the minimum on that. Well, I won't be doing this for very long because my minimum trip is at 12.6. So temperature's climbing a little bit, and that's what oh shoot. So what I got to do, I'm going to tune out and go back and lower this voltage as well. I came back and to this video a little sooner than I said. It's 22 minutes in. I have increased the current now to 4 amps. While you weren't looking, I lowered the the minimum voltage down to about 10 because this much current out of that battery brings the voltage down below my trip point. What I want to see is what temperature the transistor gets to. This is where you're going to be running at around 12 volts and around 4 amps. We've gotten to 30 degrees where I run it, which is a couple amps and 16 volts. So you can see the temperature's climbed just a little bit while I've been talking, but it looks like it's going to stabilize maybe in the low 30s, maybe 35. I'm under 40. I'm a happy guy. 40 degrees centigrade is 100 degrees Fahrenheit. That's pretty cool for a transistor. That should be fine. All right, I'm going to turn the video off and let this run just a little while to see what happens. So it's a couple of minutes later, and we're stabilized at 36 degrees C. Can't tell you how happy I am about that. So you're going to be able to run your test without blowing up your unit. So hopefully you won't ever need those spare transistors I gave you. I'm going to block off one of the fans now, just out of curiosity to see what happens to the power. You can hear the thing rubbing against the card a little bit. Get a little better blocking job. Yeah, that took it up to 37. Maybe now it would get to 40. Well, it's certainly not dying. Okay, well, I'm pleased with that, and that really concludes our little demonstration of how to use this thing. I'm going to now take this current down to 0 and see what my battery voltage is. Okay, so I'm at 15.5 volts, so I haven't even discharged this by 50%. 50% would be 3.7 times 4. What is that number? I'll just get out the trusty calculator. 3.7 times 4. Oops. 3.7 times 4 is 14.8. So we're at 15.6. We're a good deal above 50% discharge. I've pulled an amp hour out of this battery. I have no doubt it would get to the more than 4,000 milliamp hours, especially if I ran it down at my half amp, which is where I run it on my float tube. So enjoy this thing and have fun with it.